Today we'll be talking about the physics behind softball. For batting, most people think that in order for the ball to go as far as possible, one must maximize the distance from the hand in order to increase the work done, which in this case is the energy transferred from the bat to the incoming ball. Here, the distance S refers to the distance of which the force from the batter is applying to the ball. S is directly proportional to D, which is the distance from the contact point on the bat to the handle. Hence, we arrive at this, that work done is proportional to the force times distance. The one thing that people forget is the energy lost by the ball to the bat. In reality, most of the kinetic energy actually comes from the incoming ball rather than the swinging bat. As seen from the equation, kinetic energy of the outgoing ball equals to work done by the bat on the ball plus kinetic energy of ball minus energy lost to the bat. Let's take a look at this graph. This is graph of bounce factor against distance from handle of the bat when a ball is batted against a stone wall. Bounce factor refers to ball exit speed divided by incident speed of ball, where we assume that bat is at rest. As seen by the graph above, the optimum point for the ball to hit the bat is at around 17 cm. This is also known as the sweet spot of the bat, where the bat is known to be least sting to the hand and the ball will fly out at the greatest speed. This is because minimum amount of energy is being converted from the kinetic energy of the ball into energy for bat vibration. Hence, as shown by the equation Ke equals to half mv squared, the velocity of the reflected ball will naturally be slower. The speed of the ball all depends on the energy in it. Seeing that the work done by the hand is negligible as compared to the kinetic energy of the ball, kinetic energy in exiting ball equals to kinetic energy in incoming ball minus away the energy lost to vibration. Hence, in order to maximize the kinetic energy in the exiting ball, we will have to minimize the energy lost to vibrations. By landing the ball at the sweet spot, this amount of energy is lost to the bat, hence allowing the returning ball to be at its maximum velocity. Now we'll be talking about the myth behind pitching. The myth behind softball pitching is that strength is the only factor contributing to the speed of the fast-pitched ball. However, the velocity of the ball comes from the windmill motion, which is a circular motion. From the equation Fc equals to mv squared over r, we can derive the equation that V equals to square root Fcr over the mass of the ball. In this case, the centripetal force is provided by the tension in the arm. This tension is the potential energy in the arm, which is the strength of one's arm. This energy will then be converted into mechanical energy through the contraction and extension of the muscles. And since mass is constant, by referring to this equation, we can see that the speed of a pitch does not solely rely on the pitcher's strength, but also the radius of the circular motion, which is determined by the length of the arm. There is a myth that the fastest runner is able to steal any base. When the pitcher pitches, the runner are allowed to start running. Stealing base is when you run from base to base without getting tagged out by a fielder. People call it impossible as you only have the time at which the pitcher pitches. The catcher catches and throws it to one of the fielders to tag you out. That's the time from P to C and to third base. To test that myth, we will see if Usain Bolt's speed is sufficient to cover the shortest distance from base to base, which is, for now, is second to third base. He only has the time which the pitcher pitches, the catcher catches, and throws it to the fielders to take him out. Of course, in order to see if this is possible, we have to make some assumptions. The first assumption would be that objects are moving at constant speed. And the second would be that Usain Bolt is able to stop instantaneously at the base and will not overrun. The third one would be that fielders have the lowest human reaction time, which is 0.215 seconds. Looking at the equation, S equals to ut plus half at squared, Since A equals to 0, S will be equals to ut. Now, in order to calculate, we have to use the kinematics equation S equals to Vt. To calculate the time taken for ball to travel from P to C and to third base, we have to find the distance between P and C divided by pitching speed plus the human reaction time of the catcher plus the distance between C and third base divided by throwing speed plus human reaction time of the catcher. And after calculation, we will get 1.14 seconds. For now, we will find the time taken for Usain Bolt to run from second to third base. It will be the distance between second to third base divided by the speed of Usain Bolt, which is 1.61 seconds. Okay, in conclusion, we can see that Usain Bolt will take a longer amount of time to reach the base as compared to the time taken for ball to travel from P to C and back to third base. Hence, this myth is busted.
10 meters, that's when I determine if I've won. Because last 10 meters, you're not going to catch me. No matter who you are, no matter what you're doing, no matter how focused you are, no matter how ready you think you are, you're not going to catch me. Because that last 10 meters is going to take me 3.5 strides to pass the finish line.